Calculating with powers, again, is a skill you need to be able to do without a calculator in the same way as working with negative numbers. You need to understand what is happening. That way you can check what you've done on the calculator to make sure it's correct. So let's go through these ones. 9 to the 11 times 9 to the 2. Well, the base numbers, we call it, that's these numbers here, the big numbers are the same. In fact, on all of these questions, the base number will be the same. So when we have that and they're multiplied, we literally add the two powers together. So we've got 9 to the 11 times 9 to the 2, which is 9 to the 11 plus 2, or 9 to the 13. The one below, we have 2 to the 5 times 2. 2 can be considered as 2 to the 1. So we've really got 2 to the 5 plus 1 in terms of the powers, and 5 plus 1 is 6, so that's 2 to the 6. I would have 6 2's there multiplied together. The next one, I have 8 to the 5 multiplied by 8 to the 0. So you could do it like this. You could say it's 8 to the 5 plus 0. Well, 5 plus 0 is just 5. So it's 8 to the 5, which is what I started with here. The thing to note, anything to the power 0, in this case 8 to the 0, is equal to 1. So if we had a to the power 0, a being any number to the power 0, it's always equal to 1. So bear that in mind. When you see that, it does crop up a lot in exam questions. Moving across to the other column, we have divisions here. So we have 10 to the 12 divided by 10 to the 6. When you do that, you are subtracting the powers. So it's 10 to the 12 minus 6. And I don't know if I wrote 10 there, sorry. So it's 12 minus 6. And 12 minus 6 is 6. So the answer is 10 to the power of 6. The next one then, we have 4 to the 21 divided by 4. Remember, a number on its own is just to the power 1. So I have 4 to the 21 minus 1, and 21 minus 1 is 20. So I have 4 to the power of 20. The final one here, there's two ways you could look at this. You could go, it's 5 to the 3 minus 3, which is equal to 5 to the 0. And anything to the power of 0, as we've seen, is equal to 1. Or, of course, you could just look at this and go, hang on, I have one thing and dividing by the same thing. Anything divided by itself, well, that's going to be 1. So you could go straight to the 1. Often with power questions, you might have a division written as a fraction, but it's exactly the same thing. So here we have 8 of them. Let's have a look. The first one here, we have 2 to the 10 over 2 to the 4, which really means 2 to the 10 divided by 2 to the 4. And you know the rule with division is you just subtract the powers. So it's 2 to the 10 minus 4, and 10 minus 4 is 6. We don't need to really write that step in. But I will write intermediate steps on all of the rest of these questions, but in a slightly different way. So what I've got here in the next one, I've got 8 to the minus 1 divided by 8 to the 2. So that is 8 to the minus 1 minus 2. I'm subtracting the power of the denominator. So it's minus 1 minus 2, and minus 1 minus 2 is minus 3. So my answer is 8 to the minus 3. With the next one, I have 10 to the negative 12 divided by 10 to the 7. So it's minus 12 minus 7. You take away the power, whatever the power is. In this case, it's 7. And minus 12 minus 7 is minus 19. Now, the next one you need to be careful with because it's 3 to the negative 6, and I am subtracting the power. The power is negative 1. So I'm subtracting negative 1. So what have I got here? I've got 3 minus 6 minus 1, which is the same as minus 6 plus 1, and 3 minus 6 plus 1 is equal to minus 5, so my answer is 3 to the minus 5. I'm subtracting this power, so it's minus 6 minus 1. Minus 1 is plus 1, minus 6 plus 1 is minus 5. Moving across, we'll do the top first, and then we'll do the bottoms on these ones. So the top of my fraction is 3 to the 8 times 3 to, 3 to the 3 times 3 to the 5, which is 3 to the 8. So I've got 3 to the 8 over 3 to the 2. And then I take the powers away. So I've got 3 to the 8 minus 2 is 3 to the 6. So I added these two powers, and then I took away this power. Same for this one. So I'm going to have 6 to the negative 2 plus 4. So that is 6 to the 2 over 6 to the minus 8. And then I do 2 minus 8, which is 2 plus 8. So I get the answer of 6 to the power of 10. So again, I added these two numbers, negative 2 plus 4, gives me 2. Subtract negative 8, which is the same as adding 8, give me a 10. With the next one then, I'm going to have 7 to the minus 4 minus 7, add minus 7, so that's minus 15, over 7 to the minus 4. Minus 15 plus, minus 4 is 7 to the minus 15 plus 4, which is 7 to the minus 11. So again, what I did here, I added these two powers, giving me minus 15. I subtracted negative 4, which is the same as adding 4, and that gave me minus 11. The final one, the top I leave alone, so it's 14 to the negative 3, over, I've got 14 to the negative 11 plus negative 19, so that's negative 11 minus 19, so that's minus 30. And then I do minus 3 minus minus 30, which is 14 minus to the power minus 3 minus minus 30, which is 14 to the minus 3 plus 30, which is equal to 14 to the 27th power. Again, this one left alone, I do this, add this, give me minus 30, and then this, subtract negative 30, which is plus 30, give me 27. With scientific notation, we need to have numbers where we have a number multiplied by 10 to a power. So my number I'm going to call A, and my number A must be greater than or equal to 1, but less than 10 for it to be in scientific notation. The n can take any value. If it's a big value, so a number that is positive, okay, we'll have a very, very big number. If my number is negative, I will end up with a very, very small number, which will be less than 0. It won't be a negative number, but it'll be a number less than 0. So here we have both numbers written in scientific notation. So we have 8.6, that's between 1 and 10. And I have times 10 to a power, so it meets the requirements here. With the second one here, I have 2, which again is between 1 and 10, times by 10 to a negative power, so it is in scientific notation. If I had something like 12.4 multiplied by 10 to the 3, that number then is not in scientific notation because that number is bigger than 10. So that would not work. And the same as if I had something like 0.32 times 10 to the 4. My 0.32 is not between 1 and 10, so it's not in scientific notation, so I can't have that one either. Calculating with scientific notation, multiplication is easier than the division with these. If we look at the first one, quite often they're presented in brackets here, as we see here. But if you think about it, those brackets aren't actually doing anything. So what I really have is 7 multiplied by 10 to the 6, multiplied by 3 times 10 to the 18. Now you should know when you multiply, you can change the order. It does not change the result of what you've got. If I had 2 times 3, it's the same as 3 times 2. So I can switch the order here, and what I've actually got here is 7 multiplied by 3, multiplied by 10 to the 6 times 10 to the 18. 7 times 3 is 21. And I have 10 to the 6 times 10 to the 18, which is, adding those powers, is 10 to the 24. Now this number here is not in standard form or scientific notation. So I need to change this. I need it to be 2.1. But 21 isn't equal to 2.1. 21 is equal to 2.1 multiplied by 10, or 10 to the 1. This is equal to this. So that would then be multiplied by 10 to the 24. So this equals this. Now, this is the first part of my standard form, or scientific notation, but this needs to change. 10 to the 1 times 10 to the 24, well, that's 10 to the 25. So I've really got 2.1 multiplied by 10 to the power of 25, and that is in scientific notation, so that is correct. Just quickly going through that again. I can remove the brackets, and I can bring the two ordinary numbers, as we'll call them, to the front. My 2 powers of 10, I stick at the back. I work out my ordinary numbers at the front, and I work out my powers of 10. Then I look to see if it's in scientific notation. It's not, so I change my 21 into something which is a number between 1 and 10 times by 10 to a power. And then I equate my power, I sort out my powers of 10 again, and then my answer is finished. Now, in terms of division, I like to see division as a fraction with these. So what I've really got is 1.6 times by 10 to the negative 4 divided by 8 times by 10 to the 13. Now I've got a fraction here, and I can actually split this up. I've got 1.6 over 8 multiplied by 10 to the minus 4 over 10 to the 13. Now just stop for a second and look at that, because if I went the other way, if I'm multiplying this fraction by this fraction, you would just do 1.6 times 10 to the minus 4, that's here, 8 times 10 to the 13, that's here. So I've just really gone backwards in terms of my multiplications. Now, looking at the numbers here, 1.6 divided by 8, that is equal to 0.2. And 10 to the minus 4 over 10 to the 13, well, that's 10 to the minus 4 minus 13, which is 10 to the minus 17. Now, this number is not in scientific notation because this number is not between 1 and 10. So 0.2 is equal to 2 multiplied by 10 to the power of negative 1. These are the same. And then I'm going to multiply by 10 to the minus 17. So this line is equal to this line. Now I can just sort out my powers of 10 here. 10 to the minus 1 times 10 to the minus 17. I add the powers in this case. So it's 2 times 10 to the minus 18. So when dividing, write it as a fraction. Do the ordinary numbers as a division. Do the powers of 10 as a division. Look at your answer. If it's in standard form, great. If it's not, change the first number so that it becomes a number between 1 and 10 multiplied by 10 to a power, and then sort out your powers of 10. So hopefully you're getting the hang of this now. Let's go through this one a little bit quicker. The first one, I'm just going to put the two ordinary numbers together at the front, so 6 times 4, multiplied by 10 to the minus 11 times 10 to the 28. 6 times 4 is 24. 10 to the minus 11 times 10 to the 28 will be 10 to the minus 11 plus 28, so 10 to the 17. 24 is not between 1 and 10, so I'm going to make that 2.4 multiplied by 10 to the power 1. Again, this is equal to this. And then I'm going to multiply that by 10 to the 17. And now all I have to do is 2.4 multiplied by 10 to the 1 plus 17 is 18. That is my answer in scientific notation. The next one I'll do is the division, as we saw on the previous screen. So 2.4 times 10 to the negative 8 over 4 times 10 to the 55. 2.4 divided by 4 multiplied by 10 to the negative 8 over 10 to the 55. 2.4 divided by 4 is 0.6. 10 to the negative 8 minus 55 is going to be 10 to the negative 63. It's a really small number. 0.6 is not between 1 and 10, so I'm going to have to rewrite that as 6 times 10 to the negative 1. Again, this is equal to this. And then multiplied by 10 to the negative 63. So now I've got 6 times 10 to the negative 64, because negative 1 plus negative 63 is negative 64. And there's my answer in scientific notation. And finally, two more. So I'm going to put these down as 1.2 times 7 times 10 to the minus 3 times 10 to the minus 10. That gives me 8.4 at the front and 10 to the minus 13 at the bottom. This is in scientific notation already, so I stop at that point. And then the final one, 8.6 times 10 to the 39 over 2 times 10 to the minus 20. So I've got 8.6 over 2 times 10 to the 39 over 10 to the minus 20. 8.2 divided by 6 is 4.3. That's a nice number to get. And then 10 to the, I got 39 minus 20. That's 39 plus 20, which is 10 to the 59. And again, this is in scientific notation. My number 4.3 is between 1 and 10, so I am now finished.